And then if you put a positive number here, even without the absolute value, this is correct. So it's one of those things where it's a small bug in XYZ where they add an extra absolute value where they don't need it.
Okay.
Okay.
Thank you, Professor.
Yeah, yeah. Okay. Now, so let's get going. Okay, so yesterday we did a problem that looked something like this. Well, we won't make it like that. Let's make it like this. And then let's go 98 x to the 8. Okay, so go ahead and simplify this problem. This is section 8.5. And it's rationalizing the denominator. Okay, so we first started with this. Okay. And we said that the way we could simplify this is to put them together and then simplify the inside and then split them apart again. So in your in yesterday's homework, you guys started from here. In today's homework, you're going to start from here, meaning that you'll have the same problem, but they'll be split in two pieces. So you'll start from here, you'll turn into this, and go ahead and simplify that inside. So now you have 5 over 49 x to the 6, and then go ahead and simplify the top, and then simplify the bottom if you can. Okay. So now we'll get square root of 5 over 7, and then we're going to divide the exponent by the index. Like that. And then we're done. Now, go ahead, copy, and then we'll sort of explain So the only difference for the first few problems in the section is that rather than starting from here, we're going to start with these two separated, and then we'll combine them together. Okay, now, when you're doing these first problems and the problems from yesterday's lecture, magically, there are no radicals. But that's not how the world works. It just happened to be that all those problems were created so there's no radicals in the denominator. Okay. So we have a rule. You cannot have radicals in the denominator. And this will be true for algebra 1. This will be true for algebra 2. And for pre-calc. And for trig. And for calc 1. And then for calc 2, sometimes. And then when you get to calc 3, no one cares. So this rule is something in the earlier classes where we go, you're not allowed to have a square root in the denominator. And so far we've had to deal with it because all the problems were manipulated. So you didn't have to worry about it. But now in this section, we're going to work on how do I remove a radical from the denominator. Okay, so it'll look something like this. Rationalize 2 square root of 3 over square root of 7. Okay. Now the question is, why is this such an important rule now? And then why does at some point nobody care? The reason why right now is the answers we have are pretty small like this. You know, they don't take up a lot of space, and rationalizing it is you'll learn to see it's not a very difficult thing. Once you get to calc 2, some of your answers will look like this, just big monster ugly things. And to rationalize it, it doesn't, one, it's time consuming, and two, it sometimes makes the answer more complex. So when you start getting into calculus, and for those of you taking me for business calculus, you have a lot of options for the answer. And then when you're looking at these different options, sometimes students will go, how do I know which way I should answer it? And I said, as long as simplifying it doesn't make it more intuitive or doesn't make it faster, I don't care if you do it, if you simplify it or not. That in terms of work, that always been my general philosophy, that either it's faster or more intuitive. Otherwise, don't manipulate the equation, because why bother? So once you get to calc 2, the answers get so big. Rationalizing the denominator, getting rid of the radical in the denominator, will sometimes add complexity needlessly. Okay, so let's talk about this. So you don't have to copy what I'm going to write. So if I write this, if you simplify it, it turns into 1/2. And the reason why you would simplify it is because this is more intuitive, and it's also faster to multiply by 2 or divide by 2 than it is to multiply by 512 and divide by 1024. So the whole point of simplifying is it more intuitive? Is it easier to deal with? So if I went to NASA and I turned this in, they would make fun of me because I should turn this in. Now, when we rationalize something, just know that this and this are the same value. So if you had typed this into your calculator and you had typed this into your calculator, you would get the same decimal number. Now, if I went to NASA and I said, it's this or it's this, they would not care. If you work at NASA, you intuitively know, oh, this and this are the same thing. So I don't really care. Either answer is correct. Okay. Now, before you develop that intuition, what we want to do is just say, hey, if you get this, you have to rationalize it, meaning you have to turn it into this, meaning that you cannot have a radical in the denominator. So once you get to about here, you kind of are able to see it really well. So that's another reason why as you move up in levels, at a certain point, nobody cares. Okay. But right now, since you don't have that intuition, we're going to build it into you by having this rule for the next few classes. Okay. Now, I'm telling you that we can't have a radical in the denominator. Why does the question say rationalize? Now, let's remember what a rational number is. A rational number can be written as a fraction. And then you go, well, what's an irrational number? An irrational number is a number that goes on forever and never repeats. Okay. And one of the easiest ways for us to create an irrational number is to give you a square root that you never resolve. Okay. So this right here is a rational number. Now, what they want you to do is rationalize the denominator, meaning that get rid of this irrational, get rid of this irrational number. That's what they're asking you to do when they tell you to rationalize it. Get rid of that square root because that's an irrational number. We want it to be a number that can be written as a fraction. Okay. Now, the way you attack this problem is that in order for me to pull out this 7, I need a second 7 in the denominator. So if I have 2 square root of 21, I now have square root of 7 squared. And my index is 2, right? Since my index and my exponent match, I could cross this out and I get 2 square root of 21 over 7 like that. So let me give you one to try. Now, since my index is 2, I need 2 5s and 2, I need 2 5s and 2 x's to free it from the radical. So see if you can do that next move. Right? Just like this, add a 5x, add a 5x, top and bottom. So what I need is I need two 5s. So I've got to add a 5. And I need two x's, so I'm going to add an x. So now I get 2 square root of 5x. These two don't multiply because the outside does not multiply with the inside, right? It's always the inside times inside, the outside times outside. So the reason why these two interact is because that's a radical and that's a radical. That's not a radical. That's why these two don't multiply. So our goal is to make that radical go away, which means that I have to have two of these 5s and two of these x's. So I have to artificially add them. Now I can't just add it on the bottom. I need this quantity to stay the same. 5x divided by 5x equal to 1. We're changing what this looks like. We're not changing how much is there. So now this 2 will cancel out with that 2 and that 2. And I end up with 2 square root of 5x. And then I'll just multiply it. Let's try another one. Okay. Okay. Now that we have, well, let me give everyone a second to copy. Excuse me. Okay. Now that we have the general idea, we're going to make it a little bit harder. I'm going to make that a 3, and I'm going to make this a little bit of a larger number. So what you want to do is take the prime factors. So 12 is equal to 4 times 3 is equal to 2 times 2. Okay. Now, in order for me to get this 2 out of the radical, I need 3 of them. My index is 3. So I need to add an extra 2 because I need to have 3 2s. And I need to add 2 extra 3s. So I have 3 3s and 3 2s. So see if you can make that move. Okay. So I need an extra 2, and I need 2 3s. So on top, I have cube root of 18. And on the bottom, I have 3 2s, and I have 3 3s. And
Professor,
yeah, go ahead.
how did you get cube root of 18 on top?
Oh, 6 times 3. Oh, I missed this 3 over here. Yeah, okay.
No, but if the cube root of 12 was 2 times 2 times 3, how come we change that to 2 times 3 times 3?
Okay, so you're asking the perfect question. So over here, I needed 2 5s and 2 x's, which is why I'm just doing the mirror image over here. Over here, since that's a 3, I need 3 2s. I already have 2, so I need only one more 2, so I have a group of 3. Over here, I have 1 3, but I need 3 of them. So that's why I added an extra 2.
Okay.
So that's the confusing part. When you're doing over here where the index is 2, you just think, oh, just multiply with the same radical. And the answer is yes, because I need 2 of each thing.
And the
When
rule
we're doing,
applies to like 4 roots and 5 roots
yeah,
if we encounter them?
yeah,
Okay. Thank you, Professor.
yeah, no problem. So we'll do a problem like that. I think the book goes all the way up to 4 roots. So we'll do a problem like that with 4 roots. So then over here, that's why I'm trying to make it so I have 3 of these and 3 of these. So over here I got 1, 2, 3. Over here I got 1, 2, 3. That's why these two things are not mirror images. Okay. So now this now turns into this 3 will cancel out with those 3s, and I get 3 cube root of 18 over 2 times 2 times 3. Now, this 3 and this 3 will cancel, and I'll end up getting cube root of 18 over 4. Let's give you another one. This is 1845, rationalize. Let's go 24, and then let's make this to the 4. Okay. So go ahead and take the prime factors of 24. Twenty-four is 6 and 4, 3 and 2, 2 and 2. Okay. So I need 4 2s and I need 4 3s. So add how many 2s and 3s you need to make this a group of 4 and a group of 3. Sorry. Make this a group of 4 and make that a group of 4. So this right here, so I need one more 2 in order to get a group of 4, and I need 3 3s. Oops, I need a 2 in there too. They need to be exactly the same. There we go. Okay, so now I have so 10 times 27. And then the nice thing we know is this is simplified. Over here, I have the prime factors. I see I don't have 4 of any factor, so we don't have to worry about simplifying that thing. Then over here, I have 2 to the 4, 3 to the 4. And what we want to do is this index will cancel out those exponents. I'm going to give everyone a chance to copy, but I want you to notice that in the denominator, there is only one term. Okay, so if there's only one term in the denominator, this is how you rationalize. So when you take trig and pre-calculus, you'll automatically rationalize the denominator.
Hi, Professor.
Mm-hmm.
And the problem in the middle,
Mm-hmm.
you know, when you're doing like the 2, 2, 3,
Mm-hmm.
and when you're multiplying it, why is it 2, 3, 3 instead?
Okay, so you're asking me the right question. Okay, let me get a different color pen. So let's just look at the denominators over here. I had this, and then I want to get to here. Okay. So what I currently have when I'm over here is 2 squared, 3 to the 1. What I want to get to is, okay, so this is what I have. And what I want to get to is 2 cubed and 3 cubed. This is my goal. I want to get to this because then this 3, that 3, and that 3 will all cancel each other out. So all I'm adding to this is what's missing. I have 2 2s. I want to become that. I need 1 more 2. I have 1 3. I need to get to 3 3s. So I'm adding 2 more 3s. So the idea here is that I'm trying to get to this because then these things will all cancel. So I'm just asking myself, how many more do I need to get to 3? How many more do I need to get to 3? That's why I get 1 here and 2 there. Does that make better sense at all?
I mean, it makes better sense, but then I'm still confused on like,
okay,
1 2 and 2 3s. So you're just off of this and nothing with the denominator.
Yes. We're trying to do. The only thing we don't care what happens on top. The only thing we care about is that if I have a 3 here, that for every factor I have exponent 3 and an exponent 3 there. So just like over here, right? We only care about the denominator. I'm trying to get to this situation where the number of 2's that I have and the number of 3's that I have is the same as this exponent, so they all cancel each other out. So over here, I've got 3 2's. I'm going to add one more. Over here, I got 1 3. I'm going to add 3 more. That way, I have 4 of these and 4 of these. Because I have a different amount of 2's than I do 3's, that's why I have a different amount of 2's and 3's over here. Same thing over here. I have a different amount of 2's and 3's over here, which is why I have a different amount of 2's and 3's over here.
Okay.
Is that a little bit better?
Yes.
Okay.
Thank you.
Huh? Okay, so then for people who are copying, I'm going to erase that so you don't copy it. Okay, let me give people just a few seconds to copy. Okay. Now, the thing here is that this is one term and then one term. And what we're going to do now is show you when we have two terms here, what is our strategy? Okay, so let me erase right here. Okay, yeah. Yeah, I did get that. Okay. So let's look at a problem that looks something like this. Yeah, that looks good. Okay. So the difference here from what we were doing over here is this has one term, this has two terms. Okay. Now don't copy this, I'm going to do it incorrectly. Okay. Let's say we use the same strategy. And what I decided to do was multiply both sides by square root of 7. Okay, don't copy because this is wrong. So this will go 2 over 5 square root of 7 minus square root of 7 square root of 7. So we get 2 over 5 square root of 7 minus 7. Okay. Now, our goal was to rationalize the denominator, meaning to get rid of this square root, this irrational number in the denominator. And all I did it was move it from the right side to the left side. So this didn't accomplish my task. So we have to use a different strategy. So what we want to do is really square root that. I know, really square that, because I know that this is true. Squares undo square roots. So what we want to do is we want to square this somehow. Okay. So what we're going to do is we're going to multiply by the conjugate. Okay. Now it's a big word. Let me explain what that word means. Now in the past we had this formula: a squared minus b squared is equal to a minus b, a plus b. These are called conjugate pairs. Okay. So the conjugate of a minus b is a plus b. They just have opposite signs. And the reason why we like to use conjugate pairs is because we like this idea of squaring this and squaring that. Okay. So what we're going to do here is we're going to multiply by the conjugate. Oops, I'm sorry. So we have 2 over 5 minus square root of 7.
Professor,
Go ahead.
would it not be multiplying the numerator
Oh,
and
by
denominator
plus.
by 5
Yeah.
plus? Yeah.
Yeah, thank you. This sign and that sign have to be opposite. Okay, so yeah, thank you. Okay, now on top, we just distribute 2 times 5, and then we get 2 squared is 7. And then on the bottom, this is the cool thing, we get a squared minus b squared. See, what we have over here is a minus b, a plus b, and over here what we have is a squared minus b squared. Ten plus 2 squared is 7. So now we have 10 plus 2 squared is 7 over 18. Now, this was something that we did at the beginning of lecture yesterday. Does any number divide into every coefficient? So let me write that down. Does any number divide into each coefficient? And the answer is yes. It doesn't always. You don't always get the situation where something divides into everything. But in this case, we do. 2 divides into here, 2 divides into there, 2 divides into there. And then we get 5 plus square root of 7 over 9. Then that becomes our answer. Now, if you just FOILed over here, you would end up getting this. It's just a little faster to go a squared minus b squared. Okay, let's try again. I'm just going to erase this very top parts for other people who are copying still. So something like this is on your homework. That's okay. Just rationalize by the conjugate. Actually, instead of a minus, let's make this a plus so we can see that what we'll multiply is the top and bottom is by square root of x minus square root of 2. So go ahead and see if you can multiply it by the conjugate. Okay, so we get square root of 3. So I'm going to multiply this by square root of x minus square root of 2 over square root of x minus square root of 2. So go ahead and distribute this over here. Then on the bottom over here, you're going to have something squared minus something squared. It's always going to be a minus in the bottom. Now this square and that square root will cancel each other out. This and this cancel out. This and this cancel out. So then you'll get square root of 3x minus square root of 6 over x minus 2. Now that may not look pretty, but our only goal was to get rid of the radicals in the denominator, and we accomplished that. Okay, let's do one last one. Okay, so let's try 6 over let's do 12. Now let's do 12. Okay, give that one more shot.
Professor,
Go ahead.
just to clarify, the one on the left, the 3x, that's all inside the radical, right?
Yeah, I was a little sloppy there, but yeah. Okay, let's multiply by the conjugate. Okay. And then I get 6, 12 minus 18 over
Professor,
go ahead.
you multiply numerator and denominator by rad 12 plus.
Plus, thank you. Sorry, I'm distracted. Thank you very much. Okay, now what I want to do here is I should probably simplify that 12. So now I have 12 minus 9. So for this one, that square and that square root cancel, but that one over there is just a regular, it's just a regular 9. Okay. Now, this right here will turn into a 2. Okay. Now ask yourself, is there some number that divides into 12, 18, and 3? And the answer will be 3.
Professor,
Go ahead.
where does the 18 come from?
Oh, 6 times 3. So let me move the 6 over here closer. Okay. So 6 times square root of 12 is here. Because this is on the inside and that's on the outside, they don't mix. But then this one right here is just a regular 6 times 3. Okay, so this section is done, which was nice. Hopefully we just do 3 sections today. So this is done. Let's go to section 8.6. Solving radical equations. So after class, I will put up the what to study. I'll try to have the practice midterm done either late tonight or by tomorrow afternoon. And I'll put up what sections to study also. Okay. So it'll be everything from what we started from to where we are today. I'm trying to make it so there's roughly 35 questions in 2 hours. And the way I'm trying to set it up is that I'm trying to do around a 20-15 split. So 20 questions are from the new stuff and 15 are from the old stuff. Okay.
Professor,
Go ahead.
I know on haiku you have practice finals, but is there like a practice midterm as well on there from like your older classes?
There are. So what I'll do is I'll do what I did before, where I will tell you the files and then
Right.
what questions to work on.
Okay, thank you.
Yeah. Okay, so let's move on to section 8.6. Sorry about that. Okay, so let's go section 8.6. So those problems look something like this. Let's make this 7. Now I'm going to put 2 questions up here so we can compare and contrast them.
On there from like your older
shoot, I
classes?
don't want to do that. -7. There we go. Right, and then this one over here. Okay, let's make this 7. Okay. Now, whenever we're trying to solve a radical equation, you're always attacking this in the same way. The first thing you do is you isolate the square root. Like that better. Meaning that I have the square root, and what I want to happen is I want to have this all by itself. Now, the way I do that is I get rid of this 10. And then I get 3. Okay. Now the next thing I do is I square both sides. Okay. Now when I square both sides, the square and the square root cancel each other out. Oops. Okay. And just like before, there's a little small print. This might be correct. Meaning, if there's an answer, that's what the answer is, but it may also be no solution. Okay. Now, what I want you to do is I want you to do the same thing here. You'll do the almost identical thing. So isolate the square root, square both sides, and then tell me what x is equal to. And then we'll sort of compare and contrast the two problems. So let's try it. Let's subtract 10 from both sides. Okay. And then we're going to square both sides. So now we get x plus 2 is equal to 9. And again, this might be correct.
Professor.
Uh-huh.
How come when you take the square root?
Oh, say that again. When I take the square root,
Or when you square each side, how come you put a parentheses around the -3?
Oh, whenever you do, so there's a rule where, let's say I have 2x is equal to 10. So the rule is anything I do to the left side, I can do to the right side, but it applies to but the way you apply the rule is you put a parentheses around it. So let me sort of show you an example. Okay, so we're used to this, and then This and this cancel, and we get x is equal to 5. But let's actually use real numbers. So let's say I use 3 plus 7 is equal to 1 plus 9. Left side, right side are equal. Now, if I just multiply this side by 2, multiply this side by 2, I get 6 plus 7 is equal to 2 plus 9. 13 is not equal to 9. In order for this rule of anything you do to the left side, you have to do the right side, you need to put a parentheses there. If you don't, it won't work. So then we get 2 times 10 is equal to 2 times 10, and then now that works. So anytime you apply an operation on both sides, even though you don't write the parentheses are there. So that's why this over here becomes a positive 9, not a negative 9.
Okay, thank you.
Yeah, it's a really good question. It's the first time I got that question. Everyone just assumes, sure, you must know math. It must be correct, but it's a really good question of why do we actually have to put a parentheses in? Okay, so again, this might be correct. Okay, now to tell whether it's correct or not, you have to double check. Meaning you plug this into the original problem. Okay. So I get square root of 9 minus 10 is equal to minus 7. 3 minus 10 is equal to minus 7. Minus 7 is equal to minus 7. We're good. That's correct. So go ahead and try the same thing on this side. Plug this 7 into here and see if you get the right answer. Okay. Now what happens is you get oh, let me use the blue pen. 7 plus 2, 9 plus 10. That's false. So this is incorrect. And your answer is no solution. I think XYZ says no solution, but does not exist, undefined. They're all the same thing. So the question is, what's the difference between these two? I thought they look almost identical. And the difference is over here. See, if I were to plug in 7 over here, that's not true. Square root of 9 is not equal to negative 3. But what happens is when we square both sides over here, we end up with 7 plus 2 is equal to 9, and that's true. So a square root can never be a negative number. But when we square it over here, we lose that fact that, hey, that square root can't be a negative number, but when we square it, we force it to be positive. So when we make this move, we introduce the possibility of error, which is why we have to sort of double check our answer, meaning that if this statement is true, then this statement is true, and this statement is true. But if this statement is false, this will then fix it so it's true. So that's called an extraneous answer. So in the process of finding our answer, we mess something up. That's why we have to double check. Now, some people will ask me, so after I isolate, if I get a negative number, I know I have the wrong answer. The answer is yes. But after you isolate. See, over here, I started with a negative number, but after I isolated, it was positive. That's why it worked. Over here, I started with a positive number, but after I isolated, I got a negative number. So if you were to go this far and have that, and you say no solution, it would be correct. So then the next question is, okay, so if I can stop here, or after I've isolated, I get a negative number, can I always assume that that's the only way to get a no solution? And the answer is no. You always have to double check. I'll give you problems where this is a positive, and when you double check it, it still doesn't work. So no matter what, you have to double check your work at the end. Okay, so let me leave this on the board. Let's take a 10-minute break. Let's come back at 9:19. Okay.
Not as good as those. Yeah. Not better.
Okay, so let's get back to this. Okay, so that's done. Okay, so if you have a square root that you're trying to solve, a square root equation, if the index is 2, you always have to double check your answer. Now, if the index is 3, odd, you don't. Okay, so let's do one that has 3. Okay. So do the same thing. except instead of square rooting, you're going to cube it. So let's say I have something that looks like this. Let's go 6 is equal to 2. Okay, so go ahead and isolate and then cube both sides. Subtract 6 from both sides. Okay. Now, even though this is negative, because this is an odd index, this can be negative. I mean, when you have the cube root of -8, we get -2. So it's possible for this to be a negative number. So if this index is odd, it's possible for this to be negative. Right? So now cube both sides. Okay. So then we have x is equal to -66. Now, if you have an odd index, don't have to double check. If you have an odd index, this just worked. That's correct. So you don't have to worry about it. It's correct. Okay, you only have to double check if there's an even index. Now the question everyone has is, well, how come? That's a really good question. We're actually going to go into the how come next week. So next week we're going to have a big section on why. Like we have some problems where we double check. We have other problems where we don't. Why is that? And we're going to explain that in about 4 days. Okay, let's try another variation. So what you want to do is square both sides. It's already isolated. So go ahead and square both sides. Okay, go ahead and work on that problem. And then be sure to double check it at the end. Oops. Oh, I'm sorry. This is supposed to be an X, not a Y. I'm sorry. I don't know where that Y came from. You'll only have one variable. Sorry, I didn't mean to freak people out. That should be an X. So go ahead, solve that. And oh, by the way, I just got a text from a friend who works at Kaiser. So her job is to look at the state data for Kaiser. She actually is the person who sets your insurance rate. Like literally you pay because what she figured out in an Excel spreadsheet. She's saying the numbers for COVID in terms of Kaiser, it's gone through the roof. The next few weeks should be exponential growth. It's really scary right now. So please, please, please stay in. These next few weeks, they're already in the bank. They're already going to explode. We just haven't found those people yet who have COVID. So please do not go to bars, restaurants this next few weeks because it's far worse than what you think it is. The data that Kaiser's looking at is overwhelming. I just talked to a person who's doing tracing for Kaiser yesterday, and she said all of their ICU beds are full. So please don't be stupid and go to the beach and go to the bar this weekend, next week, and the weekend after that. It is really bad, and the data of how bad it is hasn't come out yet, but it will. So please, please be smart this weekend. Okay. I know July 4th is coming up. Don't be stupid and go to a barbecue. Okay. So let's finish this up. My friend was just texting her friend saying, stay in because the internal data looks really bad. And then Kaiser is the biggest health provider in the state of California. So she actually knows what the real number is for the entire state. So please stay in this next few weekends, even though July 4th is coming up. Okay. Okay, so now we did the one where the square root on both sides. Okay, let me take a picture of this one. Okay. Now let's double check that. Oops, delete that. I forgot to double check it. So go ahead and double check. Okay, so we get 4 times 2 minus 6 equal square root of 4 minus 2. I get 8 minus x is equal to square root of 2. And square root of 2 is equal to square root of 2. So that's good. Okay, so let's do a new one. Right, go ahead, copy that. Okay, so let's erase this. Okay. Let's see, did I take a picture? Yeah, I did. Okay, now let's look at a problem that looks like this. Okay, so do what we've been doing all the way through. Isolate the square root and then square both sides. Okay. Isolate the square root and then square both sides. Okay. Now you go -3 minus 3. That. Okay. And then you square both sides. Now you got to be careful. When you square both sides, on this left side, the square root and the square cancel each other out. But on this side, what you're going to do is you're going to do a FOIL. So go ahead and FOIL this. Get x squared minus 3x x squared minus 6x. And the way I got the 6x is I just combine like terms over here. So I get minus x plus 1 minus x plus 1 0 is equal to x squared, like that. Okay. Now, because I have a square, what you want to do is make one side equal to 0 and then factor. Because you have this, make one side 0. Okay, and then factor it. Okay, so let's do it again. So now, when I x factor this, I get 0 is equal to x minus 2, x minus 5. So I have x is equal to 2, x is equal to 5. And then you have to double check them separately. So first double check x equal 2. Now you could have one answer, two answers, or no answers. Okay, so plug in this into here and see if it works. Okay, so we should get square root of 2 minus 1 plus 3 is equal to 2. Square root of 1 plus 3 is equal to 2. 1 plus 3 is equal to 2. 4 is equal to 2. That's bad. So this is not a good answer. So go ahead and try x equal 5. So we have square root of 5 minus 1 plus 3 is equal to 5. Square root of 4 plus 3 is equal to 5. 2 plus 3 is equal to 5. 5 is equal to 5. So this is good. This is our only answer. Okay, let's do one more. Okay, so let's do one just like this. Okay, so let's go square root of x plus 1 is equal minus 1 is equal to x. So go ahead and isolate that, square both sides, and then you're going to have to FOIL. Okay. Let's go ahead and square both sides. So let's square both sides. And then let's get so go ahead and FOIL that. And then make one side equal to 0 and then see if you get that. So we have x plus 1. So let's subtract the x and subtract the 1. So we get 0 is equal to x squared plus x. And then let's pull out the GCF. So once we pull out the GCF, this is all factored. So now we have x is equal to 0, x plus 1 is equal to 0, x is equal to -1. So go ahead and double check it. That's good, right? 1 minus 1, 0. We know that's good. So go ahead and try the other one. So this is good. So this one turns into -1 plus 1. So square root of 0 minus 1 is equal to -1. 0 minus 1 is equal to -1. -1 is equal to -1. Hey, that works too. So it's possible for both of them to work. Okay, so go ahead, copy that, and then we're going to go to section 8.8, which is complex numbers.
So we're gonna skip over 8.7, Professor.
Yeah, I usually go over it, but we're running out of time, and I want to make sure that we hit the most important sections. So we're gonna skip 8.7. We sort of went over it before, where we were graphing things like this, but start learning how to graph those. We kind of did a couple problems before, so it goes into a little more detail, but I'm just going to skip it just because we kind of touched on it, and I want to make sure we cover all the important topics. We're getting to the stage now because after today, we only have one more week, which means we're covering 16, 15, 16 sections. So I'm just trying to cut it down to the most important 16 sections. We'll cover like 95% of everything, but sometimes in the summer, we just run out of time. Okay, so go ahead, copy that, and then we'll talk about section 8.8.
Professor, are you going to keep the homework for 8.7?
No, I think I hit it, so you can't see it. Let me double check it. But I think I hit the 8.7, so you can't see it.
Oh,
I was hoping, and then when I looked at it, it's like, you just need to let it go.
okay.
The thing I don't want to do is rush.
Right.
And the other thing I want to do is I want to keep enough time that if you have questions on the really important topics, that I don't rush you through that stuff, that I entertain the questions and I go as slow as you need to for the most important things here.
Oh, yeah. I see it's not there.
Yeah. I just removed it right now.
Okay. Thank you.
Okay. Uh-huh. Okay, so what we're going to work on is what's called complex numbers. Sometimes people call them imaginary numbers. I'm going to erase this also. Now, what you're going to learn pretty soon is that if I have x squared minus 4, okay, that turns into x minus 2, x plus 2 is equal to 0. So x is equal to 2, x is equal to minus 2. Okay. Now, geometrically, what you're going to learn next week is that anytime I have a square, that anything that has a square has a shape of a parabola, and that when you solve it equal to 0, that'll give me my x and y intercepts, like that. Okay. Now, that's not this section yet. Just know that that's what's going on. Now, in the past, when I had something that looks like this, we said that that's prime. The reason why it's prime is because I can't factor it. Now, we can look at it a different way. Now, if I want to know what x is, I can't square root a negative number. This would be not a real number. So if I were to draw what this looked like, it would look like that, which makes sense, right? The way you solve this is to say when you solve this, you go, what does this mean? Oh, this is when this parabola hits the x-axis. You go, oh, where does it hit the x-axis? At -2 and 2. Like, oh, okay. And then you go, well, this parabola does not hit this x-axis, which is why that's prime, which is why this is prime. You're like, oh, okay, that makes sense. It doesn't have any x-intercepts. That's why you can't solve that problem. Okay. Now the world is nice. That's good. I'm glad that seems to make sense. Okay. Now, then came a person named what was his name? Tartaglia. Now, you know what the sad thing about Tartaglia is? Tartaglia is one of the people who came up with complex numbers. Tartaglia was named, in Italian means the stutterer, meaning that here's this guy who discovered something that you're learning today that we use all over the place in technology. It's how JPEG stores photos. It's how MPEG stores stores movies. It's how your WAV files store sound. Here's this guy who is the center of all that technology with complex numbers, and they don't remember, history doesn't remember him by his name. They remember him by his disability. When he was a baby, his town got overrun by the French. His mother, holding him, got stabbed by a soldier, and the sword went through his mouth into his mother, killed her. So he had a stutter, and he discovered something amazing. And through history, they go, "Oh yeah, that was discovered by the stutterer." So back then, if you think we were not politically correct now, imagine you cure cancer and people go, "Oh, that's that, that guy with all the zits," right? That's sad, but that's just what happened back in the day. Now, what Tautoglu sort of looked at this and said, well, I think this is because you're talking about the real number line. See, this x-axis is the real number line, right? He goes, what if we looked at a plane, meaning that right now our numbers are one-dimensional. When I go, how many kids do I have? 2. There's only one number. Numbers are one-dimensional. And this guy went, well, what if we made numbers 2-dimensional? This is the x-axis. This is the y-axis. The thing that signals that it's in the y-axis is the I. So he goes, maybe this parabola, if you were to look at 3 dimensions, maybe this parabola really does hit the complex, we call it the complex plane, at this XY location. See, remember I told you the fundamental rule of algebra is that if I have a degree 2 polynomial, I should have 2 answers. Well, we don't have 2 real number answers, but we have 2 imaginary number answers. Imaginary or complex number, meaning that the numbers have an extra dimension. See, here's the real number line, but what if we stretch it out this way so we have 2 dimensions? Okay, it's weird. Okay. Now, you're only allowed to use this extra dimension is if we tell you you can use this extra dimension. Usually the problem will say your answer may be complex. Or they'll say answer in standard form. Or they'll say answer as in A plus BI form. And then, or they'll say your answer may be imaginary. Okay. Now, just keep this on the back burner, right? I'm describing different parts of the elephant without actually showing you the elephant. So I'm describing the tusk, I'm describing the tail, I'm describing the leg. I need to describe every piece before I go elephant, and then you see it, okay? So just know a couple things. Imaginary numbers are 2-dimensional. They usually have 2 parts to them, a real part and then the imaginary part, okay? And that's because we're no longer thinking of the imaginary, of the real number line, but what's called the imaginary plane. Okay. Now, there are 2 different worlds, okay, in math. There is the real world, and then there's the imaginary or complex world. In this world, when I go -4, this is equal to undefined. Meaning that I can't touch that. I have this many kids. Right? Square root of 4 is 2. I have 2 kids. I can touch that. I can touch both of them. Okay. I cannot touch this number. Now, in the imaginary world, we have 2 extra rules because we added an extra dimension, right? Think of it like mathematical scratch paper. That dimension doesn't exist, but we can do a little math there and then convert it back into a real number. I'll show you in a second. Okay. In the imaginary world, square root of -1 is equal to I, and then I squared is equal to -1. This mathematical world has 2 extra rules that do not exist in the real world. So when I have something that looks like square root of -4, I can break that up into 2 pieces. And then this becomes I times 2. And then most people will write it with the I afterwards. Okay, let me let people copy. Okay, now, the way you want to think about this is Superman. Okay, so Superman in the imaginary world is very strong. Okay, Clark Kent in the real world is just a regular person. He's very weak. So let's say he has a piece of coal. And then he travels to this imaginary world. And because he's really strong there, he squeezes it and it turns into a diamond. Because in the imaginary world, he's Superman, he's really strong, and because he has this extra 1 rule, he can squeeze it into a diamond, and then what he does is he then returns it to the real world where he has a diamond. Okay. Now let me use a real life example. Okay. Complex numbers, probably the most common place you'll see it is in digital compression and digital, whenever they say this has been digitally remastered, they changed it into complex numbers, removed all the scratches, because with complex numbers, it's really easy to remove scratches from when you're listening to music or scratches in a picture or noise in the picture, or if you have some kind of tear in it, you can fix that using complex numbers very, very easily. Okay, so you listen to music here, and then you compress the music here. Then over here, when you return it, you have a smaller music file. And then when I press on my song and listen to it on my iPhone, I now hear it in the real world. So all of your files for movies, music, photos, they're all stored as complex numbers. So you heard something, recorded it, turned it into a complex number so it could shrink the size of the file. And then when you click on it again, it'll then convert it into music so you can hear it in the real world. So the imaginary world is this place where we have these extra mathematical rules. We actually can't listen to the music here, but we can convert it back to the real world and listen to it. Okay. Now, all of that is probably nice and confusing. Let's talk about what the hell's on my homework. And let's do that, okay? Okay. So we have two extra rules, right? We have, so complex extra rules. In this world, -1 is equal to I, and then -1 is equal, well, let me write it the other way. I is equal to -1, I squared is equal to -1, and then we write our answers in A plus BI form. So standard form is called A plus BI, okay? Meaning that our number looks like 2 plus 3i. That's correct. If you write 3i plus 2, this is wrong. The reason why is that the I has to come second. Now, the tradition is that you put the I behind the number. I talked to one of my favorite professors at Cal State is the guy who wrote the book on complex numbers. And he goes, he writes the I in front all the time. And I go, I thought it has to be in behind. He goes, nah, it doesn't have to be. I wrote the book, it's okay. Now, XYZ is probably going to take a point away, so make sure you put the I after that degree. Okay. Now, the reason why the order matters, whereas A plus BI, is that this is a coordinate point. This is 2, 3. So you always need the x-axis to come first, the y-axis to come second. Okay. All right, so let's start with a few problems. Let's say write -40 in terms of I. So when it says go ahead and use I, it's telling you that, yeah, we're in the imaginary world. Go ahead and use the I. Okay. Now we're going to simplify this the same way we have before, where first we're going to pull out that -1, and then we're going to say, are there any perfect squares that divide into 40? 4, 25, 9. You go, yeah, 4 divides into that. So now you have I times 2 square root of 10. We'll put the I in back like that. We'll hold it with tradition. Okay. Let me give you one. Okay, go ahead and try that. We should have -1, 25, 2. And then we're done. Let me make sure that that's the format they're using. Oh, gosh darn it. The book is using this format. Sometimes people will put it in the middle. Oh, sorry. The most traditional way is to put it at the end, but it looks like for these problems, they're putting that I in the middle of the number and the radical.
Professor.
Oh, go ahead.
So XYZ will mark us wrong if we did 5 rad 2 I.
I don't know. I just know that for the answer they gave me, that's what they want.
Okay.
Okay, you could try it, but I'm not sure. Just know that because when they print out their answers, they only can give me one. I do know that they do some simplification, where some things, if you are not quite the exact same as the answer they give me, they still accept it, but I don't know. Normally the I is put at the end, but you can try it. Okay, let's try another one. Let's try this one. Now, normally, if you were to come up to one of these problems, you would have to say, write your answer in A plus BI form, or your answer might be complex. Because this is a section that is only on, that is dealing with complex numbers, they're not sort of telling you, hey, they're not telling you, hey, your answer is complex. So normally what will happen, you'll say simplify, your answer may be complex. So if you were to get this in calculus, not calculus, yeah, in calculus or pre-calculus, they are dealing with the real world. They're dealing with the real world. So if you were to have that, you would just say, oh, not a real number or undefined. You have to say that, hey, we're in the real world and I's are okay. So normally what happens is you would put something like this saying, I'm letting you know I's are fair game. But just so you know, people take this class and then they go to pre-calc and then they see this and then they go, oh, let me tell you, this is 5I, and they go, oh, no, sorry, that's not a real number. We don't allow complex numbers in pre-calculus. So there's a little disconnect there sometimes. Okay, go ahead and try this. So here we get -1 for 2 plus -1, 25, 2. So you get 2I square root of 2 plus 5I square root of 2. And since this is the same thing as that, we'll get 7I square root of 2.
Professor,
Yeah, go ahead.
will this be our last section we're covering for chapter 8?
Yeah.
Okay, thank you.
Okay, let's do this. Let's take a 10-minute break. Yeah, let's take a 10-minute break. Okay, I'll leave this up there for you guys. And then we'll finish up this section. And then if we have time, I usually like to go over grad school options. You want to know what your options are to make for grad school are. are before you get too deep in your college career, so you can take the classes that prep you for it. Okay, so let's get going. Let's keep walking through these problems. Okay. Anyone have any questions? So the way you want to treat the I is treat it the same way you would treat an X. Okay. So just treat it like it's in a variable. The only difference is if you ever get an I'm sorry, if you ever get a -1, I'm sorry, I is equal square root of 1, but if you ever get I squared, convert the I squared into a -1. Okay, so let me sort of give you a few problems.
Professor, could you repeat that?
Yeah, okay. The way you deal with i's is the way you would deal with a variable. Okay, so we're going to do a bunch of problems where you go, oh, does that work just like x? And the answer is yes. You treat it just like it's an x. The only difference is if you ever get an I squared, then what you want to do is convert that to a -1. Okay, so let's do a basic problem. So treat that as if this was an x. Okay. Now you always write your answer in a plus bi form. So previously the x's always came first. In this case, I is a flag for the y-axis, so you always write the I second. So go ahead and do this like you would think you would, just combine like terms. Right, so 2 plus 4 is 6. Then 3 minus 6 is minus 3i, and then you stop. That's it. I don't see an I squared, so I don't have to do anything. I just treat it like it's an x, right? So all I'm doing is combining like terms. Combine the numbers with the numbers and the i's with the i's. So let's try doing something like foiling. Okay, so try that. So go ahead and foil it. Treat the i's just like you would a variable, an x.
Professor,
Go ahead.
for the problem on the left, how come you don't factor out a 3?
Factor out a. Oh, whenever you're doing complex numbers, you always your answer has to be some number plus some number I.
Oh,
So we never want to factor out. You always have to have this form of some number plus some number. So don't factor anything out. Just leave it like that.
okay, thank you.
So when we FOIL this, we get 15 minus 20i plus 6i minus 8i squared. Now you want to remember that the only difference between this and an x is that I squared is equal to -1. So what will happen here is I'll combine like terms. So I have minus 14i and then I'll convert that I squared to a -1. So I get 15 minus 14i plus 8.
Professor,
Go ahead.
you did 15 minus 4i plus 8 instead of 14. Was that on
Oh, did I?
purpose?
No, it's not. Oh, yeah. Yeah, it's not on purpose. It's just my copying. Thank you.
Professor, is there any reason why I squared equals -1 instead of +1?
Yeah, it's by definition of this world. When we
Okay.
created this world, right? So normally square root of -1 is undefined.
Okay.
So we created this imaginary world. It doesn't actually exist. We said, let's imagine all the math rules that we had before exist, except when this happens, we're not going to say it's undefined. We're going to create an extra dimension to save a little information. We're not going to throw that information away. We're just going to see what happens. So by the definition of this world that we created, we said, keep all the same math that we had before, but just add this extra rule.
Okay, thank you.
Yeah. Which is weird, right? And you wouldn't think that this would be so important, but the more and more computers become ubiquitous, the more and more we think like, oh my God, looking at the world with this extra dimension, there's so many extra things we can do. Whenever you see someone rotate an object, like someone throws something on a computer video game, when you're playing Red Dead Redemption and someone throws something at you and it spins. To do that spin, it's possible to do it in the real world, but it's a real pain. It's like you shift the world this way, shift the world this way, shift the world this way, rotate. In complex numbers, it's like an addition. It's really simple. So rather than trying to figure out in the real world, every time you see something spinning on TV or on a computer or in special effects, just know that the actual rotation was computed in a complex world. So we see it everywhere. We see it, the more we use computers, the more we see that, wow, this little scratch paper that's having this little extra dimension, we could do a lot of things with it. Okay, let's try another one, just like that. So I can hide it by giving you something like this. So now work on something like this. See if you can do it. Okay, and make sure you change that I squared into an I. So we get 4 minus 6i plus 9i squared. Now turn that into a -1. we'll have 9 times -1. We're gonna leave it in here like that. Okay, yeah. Okay. Now, the book says, the way the book writes these next problems, I'm not very happy with. So I'm going to write how the book writes it, but I'm going to tell you how it's normally written. Okay. So let's look at something that looks like this. This is how the book writes it. They say rationalize. Okay. Now, the correct way of saying this is to convert to standard or A plus BI form. Okay, so your answer has to be something plus something I. That's the better way of saying it. Okay, now the problem looks something like this. Okay. Now, technically, this is not in this form, because even if you put a 0 over here, this I has to be in the numerator. It cannot be in the denominator. Now, the reason why they're saying this incorrectly is they're thinking of this like this problem. And the way you would attack that problem is you would multiply by square root of 7 over square root of 7, and then I would have 2 square root of 7 over 3 times 7. 2 square root of 7 is equal to 21. Okay. Now, this problem is very much the same thing. If we were to use sort of the same idea, we have 2 over 3 times square root of -1, right? That's what I is. And what you want to do is multiply this by square root of -1 over square root of -1. We're using sort of the same idea here. That's why they're saying rationalize, but really that's not what you're trying to do. You're trying to convert it so the I is in the numerator. So what you do when you have the situation is you multiply by I over I.
Professor,
Yeah,
could you turn the I into a radical -1?
yeah. And it would still work, and then you would have to convert it back to an I again at the end. But absolutely. I mean, basically, they're using the same trick here as they are over here. So this and this are the same thing. So absolutely you can. So you get 2I over 3I squared. Now remember we said the I squared is equal to -1. So then 2I is equal to 3 times -1. So now you get 2I divided by -3, and then we're done. So all we're trying to do is bring the I up to the numerator.
And that's our final answer?
And that's our final answer, yeah. So let me give you guys one to try. Erase this. Okay, so the book will say rationalize. That's not what you're really doing. You're converting this to a plus bi form. Okay. So let me give you something like this. Okay. And just multiply it by I over I. Okay. So we have 5i over 7i squared. So you have 5i over 7 times -1, which turns into minus 5i over 7.
Professor.
Go ahead.
So an I always comes after a coefficient, is always the second term, and is always in the numerator?
Yes, everything you said was correct. Yes. Okay. Now we're going to try to do the same thing except with 2 terms. Okay. Okay, so let's say we do something like this. All right, so that's the correct way of saying it. Let's move it over a little bit. Oops. Okay. And then I guess the way the book writes it is, the book just says divide. And then it'll have something like 3 over 4 plus 2i. Oh, sorry, let's go 6. Okay. So when we have a problem like this, what we want to do is we want to multiply by the conjugate. So we want to multiply this with 4 minus 2y. Like that. Okay, and then the reason why we want to do that, and I'll give you guys a chance to copy for a second, just look up, okay, is because we want something squared minus something squared. See, I have a plus b, a minus b, so then I get a squared minus b squared every time. So then you just put the 4 and 2i in there, okay? So go ahead and copy. So let's look at what this 2i squared looks like. Okay. So when I have this 2i squared, there's a multiplication between the 2 and the I. So you get 2 squared times I squared. So you get 4 times -1. So then you get -4. So what's going on here is that I have 24 minus 12i divided by 16 minus 4. So now that becomes a plus, and I get 24 minus 12i divided by 20. Now, what you're supposed to do is make this into 2 separate numbers. So this is not okay. You have to break these up into 2 pieces. And then you have to simplify each fraction separately. So they have to be a number plus or minus a number. Okay, so let's do that one more time. Okay, so let's go 3i times 1 plus, and let's make it 4i. Okay, so go ahead and do that problem. Multiply it by the conjugate.
Professor,
Go ahead.
the problem on the right, are we allowed to leave our answer as 6 minus 3i over 5, or do we have to break them up into 2 fractions?
You have to break them up into 2 pieces, which is why I hate how it says divide. It's really not dividing, because you really need to put it in this form. That's really what they want. So if you look at other books, they'll say convert to a plus bi, specifically because this is not, even if you simplified this, this is not an okay answer. This and this need to be separated. Oh, really? Huh. This is really weird. On problem 17, just know in one of the problems, they didn't separate it. In real life, you'll always separate it. And then when I give you this problem, I'll give you the one that is separated. So they do have a bug in one where they didn't separate it into two pieces. But just know that if in all your classes, they're going to want you to separate it into two pieces. So the one where they did separate is number 17. Okay, so just know that I'm guessing that if you wrote this, they'll probably give you the right answer, but I won't ask you problem 17 on the test, just because they should have broken it up into two pieces. All the other problems they did break up into two pieces. So we get 3i we get 3i plus 12i squared, and something squared minus something squared.
Professor,
Go ahead.
if multiplying by the conjugate, shouldn't it be 1 minus?
Yeah, it should be minus. I keep doing that. Every so often I'm start thinking about other things about my next meeting and I mess that up. Thank you. I got another meeting at 3 o'clock, and for some reason I'm just distracted, so I apologize. I've done that a bunch of times today. So we have 3i minus 12 times negative 1 over 1 minus 4 squared I squared. So we have 3i plus 12 over 1 minus 16 times negative 1. And then 3i plus 12 over 1 plus 17. 1 plus 16, sorry. So I get 3i plus 12 divided by 17.
Professor?
Yeah, go ahead.
Does it matter if the 3i is on the left or the right?
Oh, shoot. That was the last thing I was supposed to tell you guys. I did that on purpose. The I has to be on the right. Sorry. Yeah. So the I always has to be on the right. So yeah, thank you. Let me delete that and take a better picture. Okay. Okay, so there's two more small pieces on this section. So let's do both of them. Okay. One small piece looks like this. Okay. And the idea here is always pull out the i's first. You're not allowed to go -2 times -6. You always pull out the i's first. Okay. So this turns into -1, -1. So you can only multiply positive numbers. You're not allowed to multiply negative numbers. So you always have to pull out the i's to make these radicals positive numbers. So then you get I times I, 2 times square root of 6. So then you get I squared, and then you have to simplify that. So no matter what, you always pull out the i's first. Otherwise, you'll get the wrong sign. Okay. So over here, the rule is you can't multiply negative radicands. Radicands mean the number that's on the inside of the square root.
And likewise for division, right?
And likewise for division, yes, same thing also. Always pull out the i's first. So that way you're only dealing with positive constants inside of the square root. Okay. And then the last one I wanted to do is this one here. Okay. We want to work on this one. Let's say 42. Okay. Now, what you want to do whenever you have all these i's like this is you want to divide by 4. So 42 divided by 4 is equal to 10, 40, remainder 2. So this is equal to the remainder after you divide by 4. So this right here.
Professor?
Yep.
Why did you divide by 4?
Okay, I'll show you why in a second. Remainder when you divide by 4. I mean, you're asking the smart question. Okay. Technically, what's going on is I to the 42 is equal to, and I wish I picked a smaller number now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squared, right? Right, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and then plus 2 is 2. Now, I to the 4 is equal to I squared times I squared, which is equal to -1 times -1 is equal to 1. So what's going on here is this is equal to 1 times 1 times 1 times 1 all the way down to 1 times I squared to the number 1, right? So every time you multiply by I to the 4, you're actually multiplying by 1. So this is equal to this times a whole bunch of ones. Does
Professor.
that make better sense? Go ahead.
But what if we had like I to like to the power of 26?
Same thing. You'll divide by 4.
So it's always by 4.
Always by 4, because I to the 4 is equal to 1.
Right.
So it'll be 10 ones times I squared. Okay. So then this I is equal to -1. Okay, so let me give you another one. Let's say I to the 403. So this is equal to I squared times I is equal to -1 times I is equal to -I. Okay, we'll do one last one. I'm sorry. 4 goes into 40 10 times, remainder 0. So this is I to the 0. And anything to the 0 power is 1. Okay. Okay, now I got 12 minutes left. What I want to do real quick is go over some of your grad school options. And then if we get to 11:30, you guys are done, you guys can take off. But I actually really want to do this. The reason why is that there were 2 competing issues that was going to cause a recession. We knew they were going to come. We didn't know which one was going to come first. One was we knew retail was going to die. We knew that Kmart's going to die, Borders is dying, JCPenney's is dying, Sears just died. We knew that a whole bunch of people were going to be unemployed because of retail. COVID just made that happen right away. The other thing that we know is that there's going to be a recession that comes from people who can't pay off their college loan. We know. So once we get over COVID, we know that the next recession will be because people overspent on their education. So what I want to do is I want to go through graduate school options so you know which ones pay for themselves, which ones don't, And as you go through your classes, you can start asking your teacher for just better advice. Hey, you're a sociology teacher. If you had to do it all again, what would you get into? What would you study? Where would you go? Can I pay off my loan? Okay. Now, for some people, graduate school is a great opportunity, was for me. And for other people, it's an anchor that they'll never pay off ever in their life again. So I want to just give you the basic framework. So when you take your future classes, you can just ask your teacher, and then you can get informed information from people in the business. Okay. So what we're doing right now is most of you are working on your AA. That's your general ed. Now, most people don't like the general because they're like, I don't want to take a math class. I'm a sociology major. What the hell do I care about math? And actually, your general courses are the classes that help you to actually be a manager. Can you write? Can you do math? Can you read a research paper and understand the basic statistics? The reason why, if you're white and you're taking an African American studies class, is because you will hire people who are African American or Hispanic or gay, and you need to be able to have the right vocabulary to talk to people. Even if you're not racist, if you use a vocabulary that is inappropriate, and we have, I have blackballed people in a job interview. We always ask them, what is your experience working with minorities? And if they say, my best friend is black, blackball. Not because they're racist, is because I cannot have a person who can't speak about race coherently in front of a group of 40 students, half of whom are going to be minorities. Okay. So your general ed, while you think these aren't the classes I want, these are the classes that make you a better manager. Okay. The next 2 years is called your upper division. And people usually really like your upper division because this is what you came to school for. I came to be a nurse, and now I'm learning nursing. I came to be a sociology major. Now I'm learning sociology. So this is going to be your bachelor's. A bachelor's art or bachelor's science. This usually takes 4 years. For people working part-time or have kids, it takes a little bit longer. Okay. Now, what I tend to like are majors where after my bachelor's, I have a middle-class job. So the question is, what's middle class? Middle class in California is $65,000. Does middle class buy you a house in California? Probably not. Okay, so understand that middle class is 65K, and if you're working alone 65K, you're probably not going to have a house. Okay, so that just gives you a general guideline for when you look at data and they go, how much does this person make? Okay, now I like a bachelor's that after my bachelor's, I'm in the middle class. Some of the bachelor's where that doesn't happen is like chemistry. Even though it's a STEM major, and biology, even though it's a STEM major, if you don't want to be a teacher, the number of jobs that are out there are decreasing. People who work in a lab are having the work becoming automated. We have big machines do what people used to do. So the number of chemistry and biology jobs are shrinking. So if you just go like, well, people tell me there's always a career for science, that is not true. Okay, a psychology major makes more money than a chemistry major. So which science you pick matters. Now, I like a bachelor's that gets me into the middle class, and the reason why is that if I get C's, I still want to be middle class. So make sure you're not in a major that doesn't prevent that. Okay. Now, the next thing are professional degrees. Generally, professional degrees are expensive. You can get a scholarship, but they're usually expensive. They're a doctor, lawyer, teacher, nurse practitioner. Like certain ones really pay for themselves. Like if you're a nurse practitioner, it seriously ups the amount of money you get. If you get become a nurse practitioner very early in your career, it really bumps your salary. Now the problem is lawyers and lawyers and MBAs normally don't pay for themselves. It was previously thought that the more lawyers you had, the more money they would make, because if you have a town that has 2 lawyers, they'll sue each other. If you have 3, that's just more people suing each other. And what we found out is that companies decided that they no longer need lawyers for a lot of things that they did their business in. They can just hire an accountant. An accountant is way cheaper than a lawyer. So a lot of law jobs that paid a lot of money at these really nice corporate gigs, they don't exist anymore, because companies have decided that, why do I have to pay for Johnson Johnson and Schwartz when I could just pay an hourly rate at my accountant to do my taxes? I only need a lawyer for the things that require a lawyer. It used to be corporations were very proud of who represented them, and they didn't mind paying a premium that made them feel well. Now people have realized that, oh my God, that's a waste of a lot of money. So lawyers are having a very hard time paying for themselves. So are MBAs. So this is a master's of business. Okay. Now, most of my friends have an MBA, but then again, most of my friends are computer majors or math majors. They're not actually business people. And what happens is, you start out as a programmer, you work for IBM, you work for Oracle, and what will happen is that at a certain point, they'll go, you know what, you're really good, and we like your personality. We'd like you to be in charge of a team. And then you're in charge of a team for a while. After a certain point, they go, you know what, you're really good at being a team leader. What we want you to do to be is upper management. We want you to be in charge of a bunch of teams. At that point, they go, you're going to be representing tens of millions of dollars. So we want to make sure that you're as good as you can be. We will send you to Harvard or Yale or Stanford or Berkeley to their online MBA program. So an online MBA program is usually paid by a corporation, and it's free because your company is paying for it. So most of my friends have an MBA, not one of them paid for it. They were just good at their companies, and they would, while they're working, they would on the weekends work on their MBA. Now, if you go to USC and get your MBA, there's a decent amount of chances that you'll never make up the money to pay back the MBA. That's what the data shows right now. Most MBAs don't pay for itself. The other thing that's important when you get an MBA is that when I get a corporate paid MBA, I'm working on an online class, and everyone who is in my class are other people that a company said, you're great. Not only are we going to promote you, we're going to spend an extra $300,000 for you to do your own training. So the people that you meet, that you network with at these corporate MBAs are much better than someone who goes, I went to Valley College, I went to UCLA, now I'm going to quit school, quit work, and I'm going to go to USC and pay it out of my own pocket. Everyone you're meeting at USC is mostly unemployed. But if you get one of those corporate ones doing it online, not only is it faster, not only is it free, the people you meet and network with are probably better. Okay. So I tend to shy away from professional degrees. I'm not saying don't be a doctor and don't be an MBA. I'm saying if you're going to pick these, then you need to know why you're doing it. What jobs does this open up that you couldn't do before? Don't assume the degree itself pays for itself. It does not always. So if you say, hey, Dr. Kwai, I'm going to be a lawyer, I'll ask you, where are you going to go? What are you going to do? What does this open up for you? And will it pay for itself? And if you can answer those questions, I'll go, great, awesome. I'm glad you looked at it. And if you don't, I'll say, whoa, 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 whoa. Before you take out a loan, wait. Know why you're doing it. Don't do it just for more school. Okay. Now, so for this option, I just say buyer beware. Someone had a question?
Yeah. So would you say that getting a PA is better than getting like a doctorate degree?
Not
Because
necessarily.
I'm
It depends on
trying
your
to go to
age.
PA school, but I'm like always debating, telling myself like if I should just go for the full on doctor, or if I should just stick to my PA program.
it depends on what you want your day to look like, right? The PA is nice because you're not making that financial commitment. To become a doctor, you're looking at a $500,000 loan.
Yeah.
Meaning that you've got to make it, right? So you've got to want to be a doctor because that's the kind of job you want. You want to be in charge of a floor. If you're a PA, you're always going to take orders. Now, people may ask your advice, but at the end of the day, you cannot represent money.
Yeah.
Same thing with a nurse practitioner. So it's really a question of, do you want to be in charge or not?
Okay.
Right? And, for me, I like being in charge. But for my wife, she doesn't. She's a nurse. She doesn't want to be in charge. She shouldn't pay for the career that puts her in charge. She should pay for the career that says, that's good. Make as much money following what someone else tells you to do, right? So I think the PA nurse practitioners are no-brainers. In terms of having a chem degree and then being a PA, the amount of money you make is huge. So I think those are no-brainers. If you can get into any one of those programs, go. And I think the doctor you have to really know that I want the difference that being a doctor makes. I want to be in charge, and I want to be in charge of money. I want to be in charge of policy. I want to be in charge of who gets hired.
Yeah.
Does that make sense?
Yeah.
It's not the patient care part. It's do I want to have control of my environment? Some people do, some people don't.
Yeah. Okay. Thank you.
All right. Now, the next part I like are what's called licenses. So this is like a CPA, a certified public accountant, a CFA, a financial analyst, real estate. The reason, actuarial. This is for math. So the nice thing about CPA, CFA, actuarial is these are all like really well-paying jobs. I mean, you're in the six figures and they don't cost a lot of money. So what a license is that I go to CSUN and I go get an accounting degree and I get a job at a accounting firm. And then on the weekends, I study for this test. Now, maybe I paid $3,000 to go on to, like one of those test prep places. Or maybe I just buy the book and study on my own, right? Once you pass the test, you are now a CPA. You are now a CFA. You are now an actualist. You don't have to take a GRE exam to try out. It doesn't matter what school you go to because you're not going to school. I'm studying over the weekends, and then I take a test that proves I have that knowledge. So the nice thing about CPA is that there's no gatekeeper. At any point you decide, you know what, I'm just going to be miserable for the next 3 years, every Saturday and on my holidays, and I'm just going to study for this test. And all of a sudden, it significantly bumps your grade, bumps your salary. Now, the CFA and the MBA, they compete for the same job. So if I were you and you go, I really want to compete for that job, I would do the CFA because this is free. This is expensive. If you're going to compete for the same job and you're going to just study for 2-3 years, why pay someone? Why pay for a big building? Why not just pay for someone to help you pass that test so you have the same skill and then you compete for the same job? So I do like the license a lot because these are cheap. Right? So they significantly increase your pay. And they don't. There's no cost to it, and you don't have to not work because not working is expensive. Okay. Now the last one is master's and PhD. And for the person who's saying I want to become a PA, let me tell you, you have a fallback option also. So a master's and a PhD are exactly the same thing for the first 2 years. Take an exam, and then this is 2 years of classes. Okay, so your 2 years of classes feels like this, and some people will tell you it's even easier. The reason why is over here, your upper division, we're going to curve it on like a B-. So if you're an average student, you get around a B minus. Over here, we curve the classes at an A minus. So if you're an average student, you get an A. If you're below average student, you get a B. The way they grade these things are much easier. Okay. So even though you're going through harder topics, you're just a much better student, and the curve is set up for you to pass, unless you work really hard not to. Okay. Now, after your PhD, you then try to find something new. That's what a PhD. I am Dr. Kawhi because I found something new in my field that was never discovered before. It doesn't have to be important, like what I discovered was not important, but it has to be new. After you find what's new, you write it up, your dissertation, and you're free, you got a PhD. Now, the difference between what a PhD and a master buys you is being in charge of money. Because you discovered something new, you can not only show that you can be creative in your field, but you also show that you can document it and that you can also explain to someone, this is new because the state of my field works all the way up to here. Over here, you're learning out of textbooks. Over here, you're learning out of textbooks, but also journal papers. So when you get your master's, you start to learn, oh, these are the journals that come out every year, and if I read those, I will now be current with my field. After your bachelor's, if I told you, what should you read to be current in your field? Most people would say, I don't know. I don't know. But after your master's, because you're reading journal papers, you start to get a little bit of a flavor of who are the people who are significant in my field, who are doing new things, and who are the people, and where do I find the new information in my field? That's what a master's buys you. But because you haven't found something new, you usually can't be in charge of money in terms of grants. So this person over here can apply for grants and be in charge of money. They can be in charge of hiring and firing people and making large decisions, or this person's going to be a worker bee. Okay. Now, a master's is worthless in some fields. So for example, chemistry, worthless. My cousin, she got a chemistry bachelor's, was working, decided to get a master's. I told her not to because it would make her more expensive for the same job. But she got it anyway. She got a master's. She was unemployed for 2 years. She was working at a market, just bagging groceries in her hometown. And people would look at her like, did you just finish your master's like a year ago? And like, yeah. But why would someone pay her when they could pay someone with a bachelor's to do the same job? Because the master's did not increase the amount of things that she could do. It just made her more expensive. So it took her 2 years to find a job. She finally did, but it's always a little scary for her because she knows that she's the most expensive person doing the same job as everyone else. So before you get a master's, know if it helps you or not. Don't get a master's just to get a master's, because not only do you get the debt and 2 years of not working, you may have priced yourself out of your business. So don't do it because you automatically think. 1/3 of all professors in this country are on food stamps. Food stamps. They don't make enough money to pay their own bills. 1/3 of all professors. That includes this college. So if you look at the food bank, the sign, it not only says food for students, it says and faculty and your professor. Now, if you are a STEM major, this is free. So the girl who was talking about being a PA, just know that you have the option of being a doctor. You also have the option of being a PA. And if you want, if you get a PhD in chemistry or biology, free. Now, the PhD in chemistry and biology buys you everything because you can be in charge of money. So a company will want to hire you because I will then write a grant and ask the government for money, a grant, or the Air Force or the Navy for money, or a corporation. See, the PhD is nice because those people are in charge of money. So if you are in a non-STEM major, then you're probably going to pay for it. But there are professors on this campus, like our former president and Professor Southgate. She's sociology. Our old president was history. A lot of times schools will get a grant that'll pay for PhDs that enroll during a certain period. So if you're interested in getting a PhD in something like English, you at times can get it paid, but you need to do your homework and really call around. Call the departments directly, not through your counselor. Now,
Professor.
Yep.
Yeah, it's Sandy again. I had a question. So before I could even get into my PA program, I need to take all of my chemistry and bio, and even like organic chemistry and microbiology and all that.
Yeah.
Would you say for me to save all that money, would it be better for me to get like a PhD in like either biochemistry or something like that?
No, it depends on what you want your day to look like. Like, I have a friend who did chemistry, and his job was to make chemical warfare agents. I don't know that job's that great. I have another friend who got a PhD, and she makes medication, and her day is in the lab trying to figure out how to come up with a new idea in terms of medication. She writes grants to the state, and I'm sure that job is pretty cool, right? So it really depends on what you want your day to look like. Sometimes when this is really scary, right, because of the loan, sometimes I tell my chemistry and my bio majors, like, apply to both, and then see what your options are, right? And then see how confident you feel that if I get over the hump, I'm going to work in a hospital, and this is what my life is going to be like. And if I get my PhD in this, that's what my life will be different. You'll probably be a professor somewhere. Now, the nice thing about the PhD is that there's no risk. You're not risking any money. You don't have to worry about private school or public school or in-state or out-of-state. So they don't say it's free. Once they bring you in, you then ask all the different places that accept you, and you just say, what are my options in terms of payment? And usually what they do is like, you'll teach a few classes, we'll pay you some money, we'll waive your tuition waiver. Then after you teach for a while, we'll have you do some research, and we'll pay you for your research. So this part, for me, they just paid me to work on my research.
Okay.
And they give me a tuition waiver. So usually, so they don't say that when they bring you in, there's no promise. Once you're in, you call the department and say, how do I get this paid off? In order for them to be competitive, they have to pay for your degree.
Okay, that makes sense. Okay, thank you.
Okay, now, if you're a STEM major and you want to get a master's, like for engineering, an engineering with a master's makes more money than a PhD, because just because you have a grant doesn't mean they pay you more. If you're a worker bee and you're an engineer, you make a ton of money. So the extra years you have trying to find something new, these guys are working. So like certain degrees, like engineering, a master's is better. Psychology or sociology, if you get one that allows you to do counseling, that opens up a whole bunch of jobs that you couldn't have without that master's. So for some majors, a master's opens up everything, and for some majors, the master does nothing. And so for some majors, the master's is an anchor and it drops you down. So the important thing is to ask your teacher. Now, if I'm a STEM major, what I would do, like let's say I'm an engineer, what I would do is I would apply for only PhD programs, because you do this right after your bachelor's. Do not get a master's and a PhD. That is a waste of time and money. You go directly to your PhD. If you get your master's first, they'll make you take another 2 years of classes. So basically, you just pay to do this twice. Don't pay to do it twice. Now, because PhDs are going to become slaves over here, see, we're going to be slaves. They have to treat you well. See, after I finish my exam with a computer degree, I'm worth $90,000 in the market. They're not paying me $90,000. They're paying me $40,000 and they're waiving my tuition. So over here, they're going to make back the money in my labor. For these guys, they're never going to become slaves. So this one you're going to have to pay for. So what I always tell STEM majors is only apply for PhDs. Go all the way up to here. And if you decide you want to stop, leave. Because it was free up to here. So don't apply for this, apply for this, and then stop short, and then get that master's paid by the school rather than out of pocket. The worst thing you could do is get the master's, pay, and then go, oh, I really like this, ask to be in the PhD program, and now you're a slave. Go the other direction. Come in here, have them paid for you, and if they don't treat you well, see you later. Thanks for all that free education. Okay, anyone else have questions? Okay, anyone have questions? Oh, go ahead. Yep. 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 Okay. Yeah, so basically there are in terms of computer science, there's basically the computer engineering. So okay, there's the chip development. Then there are the drivers where you talk to them. So this is like assembly code. And then there's the full-on programmers. So if you look at, yeah. So or Python or C# or C++ or Java. You're right. You're closer to over here. So I'm going to show you where the majors exist. So electrical engineering. They are on this end of it. They do a little bit of this, but not much. Okay. Now the computer engineer, they'll do a decent amount of chip work and exactly what you're doing. The PL1 code, the interface between the chip and the operating system, and then the soldering the sensors and stuff like that. That is that's a computer engineer. Okay. Now, if you're a software engineer, or software programmer, you'll do this and you'll touch this a little bit, not a lot, but in terms of the chip, we take 1 or 2 classes on the chip, but only because we know what the chip is, not so we can actually edit it. So it sounds like what you want to be is a computer engineer. Yeah. 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 So what you are right now is, it sounds like, is an electronics guy, right? Which is, yeah. I mean, so if you were to say this, if I were to describe who you were, I would say you're over here. You're basically electronics, right? And then we have like an AA degree in electronics. There isn't a bachelor's in electronics. So right now you're electronics, so you're right here. So then your bachelor's would be either here or here. But it sounds like computer engineer is better for what your current niche is. Yeah. Absolutely. So let me the best thing to look at is this right here. Okay, so I put this up on the haiku. Let me show you. First of all, never trust a school's website in terms of how much money you make. They're lies. Always go from something like a more reputable business site like the Wall Street Journal or Forbes. But if you look at just like, because understand that schools are recruiting because you are a customer, and we make about $27,000 per student. So first of all, never get your data from a school website. So do you see this economic value of a college major? Okay, so what that'll do is it'll give you the, if you look up computer engineer, it'll tell you how much money you make if you're good at your job, how much money you make if you're bad at your job. So like, let's say are you able to see it from your computer? Okay. Normally what people do is they give you like the middle value. I don't like the middle value. What I like to know is what the spread is. So let's say I look at, here we go, computer engineering. Where is that? Let's just look at electrical, because it'll be very similar. So that's the center of how much money you make. So that is ballpark $100,000. Now, if you're bad at your job, so this is the bottom 75%. You're making 75,000, but you're still like, right, even though you're the bottom fourth of the people working with you, you're still making $10,000 above middle class. Now you go, what is my upside with the bachelor's? It's up here, it's about 125. Yeah. 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 And that's not bad, right? Just that if you're going to start making choices like, okay, now what's my upside potential? Well, if I'm better than 3 out of 4 people in my class, and you're probably going to be, right? Because if you're walking into the class with all this hands-on experience and you know what this stuff looks like, you're going to be in the upper half. The only thing that hurts you is time. You don't have as much time as these younger people. But when you walk into your job interview, you're walking with the job interview with all this electronics experience behind you and the right vocabulary for the business. So like for me, I had to break into a new business at 40. And as long as you're able to talk about how your first portion of your career informs you in your second portion of your career, all that experience usually gets you hired first over other people. Because most people are not thinking that that someone's going to work for them for 10 years. So a lot of times you're like, oh, but I'm older, and is that really going to hurt me? And what I found when I was redoing my career is it really didn't hurt me that much. is because people weren't expecting me to stay there for 20 years. Right? Okay. So now if you want to look at what the advantages of, let's say, getting a master's, if you keep on with this, right? So this, on the bottom of this will tell you electrical. So just look at electrical engineering, because that's going to be pretty close to what you're doing. This tells you with a bachelor's, and then this tells you what your potential is with a master's. So you get about a 20%. So that tells you the sort of range that you should fall in. Okay. So the best thing to do is just look at this and look at the ranges. Yeah, no problem. And then for anyone else who wants it, it's on the haiku. I just put it up there because, especially if you're like in high school, don't trap yourself in a major that's dying. There are certain majors that are dying right now, like chemistry. So if you were going to be a doctor, what I would do is I'd be an accountant or economics major, and I would take a whole bunch of all the pre-med classes. And then when I applied to med school, I would say, like, I don't want to work on the big picture of how do we get to single payer medicine. So the med schools like people who are not the same major as chem and bio. They tend to like people who have a different major. So if I was going to do something high stakes like a doctor where you have to have a high GPA to do that, I'd be like an econ major. I would take all the prereqs, and if I didn't get into med school, I still have a middle class job working in finance. Did anyone else have a question? Okay. Thanks, everyone. I appreciate it. Hang in there.
Thank you for the
Thank you.
insight, Professor.
No problem.
Have a good day.
You too.
Professor, I have a question.
Sure.
When I was looking at the PDF file,
Yeah.
My major is environment and occupational health because I intend to be a food inspector.
Okay.
So where would I fall under that?
That's a good question. So if you're a food inspector, I guess the question is, what is your promotion, right? So your promotion will be in charge of other food inspectors, right?
Yeah.
Be a manager of that. And then you go, what is ahead of that? Then, so what you have is what you're going to have is a state job. So if you go and apply for so I would just go and do that. And as you move up, the state will pay for your MBA. Most likely what they'll want you to do is, as you move up, they'll say, hey, we want you to be in charge of a bunch of teams. Could you locally go and get an MBA, and we'll pay for it? And usually the way it works is if you pass your class, the state will just pay for it.
Oh, okay.
So for you, I would not bother with trying to get a graduate degree. I would go and be a food inspector. Be really good at it, get promoted, and then from there, look around at what job you want next. And then at